In December 14, 1972, an astronaut named Cernan climbed the ladder of a lunar module sitting on the surface of the moon, looked back one final time at the gray landscape surrounding him, and spoke the last words any human being has ever said while standing on another world. "We leave as we come, and God willing, as we shall return, with peace and hope for all mankind." Then he climbed inside, the hatch closed, the engine fired, and humanity left the moon. And for 53 years, we never went back, not because we forgot how, not because we stopped caring, but because the political will, the funding, the technology, and the vision required to sustain human presence beyond Earth orbit never quite aligned long enough to make it happen. Until now. Because right now, on a launch pad at NASA's Kennedy Space Center in Florida, sitting on the very same concrete that launched the Apollo missions that first carried human beings to the moon, the most powerful rocket ever built to carry humans is being prepared for a mission that will change the course of our species permanently. And this time when we go back, we are not going for a visit, we are going to stay. The rocket that will carry humanity back to the moon is called the Space Launch System, and the numbers describing it require a moment to absorb properly. Nearly 100 meters tall, taller than the Statue of Liberty, fully loaded with over 700,000 gallons of cryogenic propellant, more volume than an Olympic swimming pool, capable of producing 15% more thrust at launch than the Saturn V rocket that first carried Apollo astronauts to the moon more than half a century ago. The Space Launch System is not a new design built from scratch. It is an evolution, deliberately engineered to incorporate the heritage and the lessons of everything that came before it. The distinctive orange core stage carrying the bulk of the propellant, the twin solid rocket boosters flanking the sides, providing more than 75% of the initial thrust needed to lift 5.5 million pounds of rocket off the launch pad. The architecture is recognizable to anyone who watched the space shuttle era, but the capability is entirely new. The Space Launch System is not designed to reach low Earth orbit and return. It is designed to push human beings and everything they need for survival out of Earth's gravitational embrace entirely and set them on a trajectory toward the moon. Everything about its design, its scale, its power reflects a single engineering requirement: get humans back to the moon and give them the foundation to stay there. Sitting at the very top of that rocket, protected by a launch abort system capable of pulling the crew to safety in an emergency, is Orion. The spacecraft that will actually carry the astronauts through the vacuum of deep space is in many ways the most sophisticated human vehicle ever built for the specific purpose of keeping people alive far from Earth. The crew module, where the astronauts will live, sleep, eat, and work during their journey, measures 16.5 feet wide and 11 feet tall, giving the four-person crew approximately 60% more living space than the Apollo command module that carried 3 astronauts to the moon decades ago. Attached to the crew module is the European Service Module, contributed by the European Space Agency, which handles propulsion, electrical power through solar panels capable of generating enough electricity to power an entire house, thermal control, and life support, including the oxygen and water systems the crew depends on for survival. Orion is designed to keep 4 people alive for up to 21 days in deep space and to bring them home safely through the most extreme conditions the return journey imposes. Its heat shield, the largest of its kind ever built, is engineered to withstand the spacecraft smashing back into Earth's atmosphere at 25,000 miles per hour, compressing the air in front of it so violently that a sheath of plasma forms around the capsule, glowing at temperatures that would destroy any unprotected material. 11 parachutes deploy in sequence to slow the descent until Orion splashes down gently in the Pacific Ocean, ready to be recovered. And remarkably, once the capsule is retrieved and refurbished, it flies again. The same capsules being prepared right now for Artemis 3, 4, 5, 6, 7, and 8 are visible in the production facility at Kennedy Space Center. Reusable vehicles that will carry successive crews to the moon across the coming decade. The crew that will fly first on Artemis 2 represents something genuinely historic in ways that go beyond the simple fact of returning to the moon. Commander Reed Wiseman, a former Navy test pilot with extensive spacewalk experience, will lead the mission. Pilot Victor Glover, a decorated flight test pilot with 3,500 flight hours across 40 aircraft types, will become the first person of color to travel to the moon. Mission specialist Christina Koch, who holds the record for the longest single spaceflight ever completed by a woman at 328 days, will become the first woman in history to visit the moon and see its surface with her own eyes. And mission specialist Jeremy Hansen of the Canadian Space Agency, a fighter pilot and space scientist on his first spaceflight, will become the first non-American ever to travel to the moon. 4 people, 10 days, a journey of 450,000 kilometers to the farthest point from Earth any human being has ever traveled, surpassing even the record set by the crew of Apollo 13. And when they get there, they will not land. Not yet. Artemis 2 is a flight test, a circumlunar mission following a free return trajectory that swings the crew around the far side of the moon, using the combined gravity of the Earth and moon to carry them home without requiring the engines to fire. It is the proof of concept, the demonstration that the rocket works, that Orion works, that the life support systems work, that human beings can survive the radiation environment and the psychological reality of deep space travel. It is the foundation on which everything that follows will be built. What follows Artemis 2 is where the true ambition of the program becomes clear. Artemis 3 will land astronauts on the lunar surface for the first time since 1972, targeting the lunar South Pole, a region of the moon that the Apollo missions never reached and that has emerged in recent decades as arguably the most strategically important location in the inner solar system. The reason is water. Permanently shadowed craters near the lunar poles, regions where sunlight never reaches and temperatures drop to among the coldest anywhere in the solar system, contain confirmed deposits of water ice. Water that has been accumulating in those craters for billions of years, delivered by comets and asteroids, and trapped in permanent shadow. Water that can be processed into drinking water for astronauts. Water that can be split through electrolysis into hydrogen and oxygen, the 2 components of rocket propellant. A fuel depot on the moon fed by water ice mined from the polar craters and processed on site is not a distant science fiction concept. It is the near-term engineering target toward which the entire Artemis infrastructure is being directed. A crude outpost at the lunar South Pole with access to water ice could be capable of manufacturing its own propellant, dramatically reducing the cost and complexity of every subsequent mission by eliminating the need to launch fuel from Earth's deep gravity well. It would transform the moon from a destination into a waypoint, a fueling station, and a staging ground for missions reaching deeper into the solar system. The orbital infrastructure being built to support the surface missions is equally significant. The Lunar Gateway is an international space station being constructed in lunar orbit, designed to serve as a waypoint between Earth and the lunar surface, a staging platform for surface expeditions, a research facility, and eventually a hub for missions extending beyond the moon towards Mars and the asteroid belt. Unlike the International Space Station in low Earth orbit, the Lunar Gateway will be positioned in a near rectilinear halo orbit around the moon, a gravitationally efficient path that keeps it accessible from both the lunar surface and from Earth throughout its orbital cycle. The Gateway is being built as a collaborative international project with contributions from NASA, the European Space Agency, the Japanese Aerospace Exploration Agency, the Canadian Space Agency, and other partners. It will provide astronauts.
James Webb just scanned 3I/Atlas, and it's not an asteroid. 3 weeks ago, the James Webb Space Telescope was quietly redirected. Not scheduled maintenance, not a routine observation window, a target of opportunity request, the kind reserved for things that don't wait. The target was 3I/Atlas, and what the infrared data came back with has split the astronomy community into 2 camps: those who think it changes nothing and those who think it changes everything. Here is what we knew before Webb looked. 3I/Atlas entered the solar system on a hyperbolic trajectory, meaning it came from outside, meaning it is not ours. It was moving at 67 kilometers per second relative to the sun. Fast, but not impossible for an interstellar object. It had a visible coma, a halo of gas and dust, which is exactly what a comet looks like. Case closed. Interstellar comet. File it next to Oumuamua and Borisov and move on. But Webb doesn't see what your eyes see. Webb sees heat. Webb sees molecular fingerprints. Webb sees the chemistry of a thing at the atomic level. And what it saw inside that coma was not what anyone expected. The infrared spectrum came back with carbon dioxide, carbon monoxide, water ice. Normal, exactly what you'd expect. But underneath those signatures, buried in the mid-infrared range, something else appeared. Complex organic molecules molecules, long-chain structures, the kind that don't form in open space, the kind that form inside something. Astronomers have a word for this: prebiotic chemistry, the raw ingredients that, under the right conditions, assemble into the building blocks of life. We've seen traces of this before in meteorites, in deep space clouds, never in an interstellar object passing through our solar system in real time. Now pair that with the trajectory data. 3I/Atlas did not enter from the galactic plane the way most interstellar objects do. It came in at a steep angle, from above, from the direction of the constellation Lupus. There are no known stellar nurseries in that direction, no obvious origin point, no star it could have been gravitationally ejected from at a matching velocity. Run the numbers backward and you don't find a home. You find an empty corridor between stellar systems that it has apparently been traveling through for longer than our models comfortably explain. And then there is the rotation. Light curve data from ground observatories shows almost no variation in brightness as it tumbles. Most rocky bodies wobble. Most cometary nuclei have irregular shapes that catch light differently as they spin. 3I/Atlas is either nearly spherical or it is not rotating the way a randomly shaped object should. Neither answer is simple. So what is it? The leading scientific position is still natural origin, an ancient body from the early galaxy, rich in organics because the early universe was chemically active in ways we are still mapping. But there is a second position gaining quiet traction in preprint discussions: that the organic complexity is too structured, that the near-perfect light curve is too clean, that the trajectory from a directionless corridor combined with a Jupiter gravity assist that added exactly the right velocity to pass through the inner solar system is a sequence of coincidences that deserves harder scrutiny. No one is saying it out loud in a press release, but they are saying it in the data sections of papers, in the careful phrasing of conclusions, in the things that get flagged as requiring further observation. The James Webb Space Telescope was not built to find interstellar visitors. It was built to see the first light of the universe, to find the atmospheres of distant worlds, to look at things billions of light years away. When it turns that instrument on something 1.8 AU from Earth, something that will never come this close again, and the result is a spectrum that researchers are describing in internal communications as anomalous, that matters. 3I/Atlas will be beyond Neptune's orbit before any mission could realistically reach it. There will be no sample return, no close flyby, no second look, just the data we collected in this narrow window from a telescope that almost wasn't pointed at it in time. And in that data, a chemical signature that does not sit quietly inside any existing category. Not a comet, not quite, not an asteroid, not even close. Something old, something traveled, something that passed through our solar system carrying molecules that took more than gravity and cold vacuum to build. The question astronomers are not asking publicly, but are absolutely asking privately, is this: was 3I/Atlas the first one we actually looked at closely enough to notice, or just the first one we were willing to admit we didn't understand? Want to be notified when Claude responds? Notify.